participants to drop their doubts in the chat box, which will be taken up soon after the session. And also a link will be provided in the chat box, so you can provide your feedback and you can download the certificate. And I request all the participants to mute yourself during the session. Now I request our resource person, Dr. Syed Hassan Ahmed, to take over the session. Over to you, sir.
Thank you. Thank you, Namrata, and thank you, Chair-elect. Just a quick question on my audio. Is it okay? Am I hearable?
Yes.
Okay, perfect. Perfect.
Yes.
That's good. That's good. So, good evening, everyone. On behalf of IEEE Mysore subsection and Bangalore section, for me, it's very early in the morning, but on behalf of your local colleagues and true hardworking professors out there, thank you so much for putting everything together. And I think you guys have done a tremendous job in, just taking a lot of introduction from my side or my slides and put together to the audience. So thank you for that. I have to just quickly go through that and skip it. Basically, today we'll be talking about connected cities. Specifically, I will be focusing on connected cars because cities are, the very first thing that comes in our mind if we are, based out of a rural area or countryside. And when we talk about cities, the very first thing that comes in our mind would be high-rise buildings. And the second thing will come up, oh, we will have a lot of cars there. So that's a reality. And definitely, I think I'm hearing some feedback. So if it's possible for admin to mute everybody, I don't know if you can do it.
Yes, Professor, you can go ahead. I'm muted.
Okay, perfect. So yeah, I was saying that when it comes to smart cities or even just a city, the one of the very first few notions that come in our mind is cars. Now, when we talk about connected cities, and I will go through the picture, I will go through the image as well, that what it really means to be a connected city to begin with. But before I move further into my presentation, I just wanted to give us a heads up that all the presentation content is completely my personal opinion. And these are the research findings or ideas that have been done before joining JMA Wireless. So it's like not my company's research or any product that I'm presenting. It's my personal independent research findings that we will be talking about. So as my colleagues on this call have already introduced me in a detailed manner, so I will just skip through this. However, I just wanted to give you the notion of some of the mascots and some of the logos of my career so far. On the left side is my education career. On the right side is my professional career or professional experience. So just wanted to give you the timeline of it, where I did my bachelor's, then I was a visiting scholar, and then I completed my graduate studies here, both MS and PhD. And then on the right side, again, I was a visiting researcher, and then I was a postdoc, and then I was a professor, and now I'm in the product line management of my company. And this is kind of a map thing. I love to see visuals, and I like to make some visuals out of almost every context that I can possibly. Some of my research summary, it's not a very latest snapshot of my Google Scholar, but anyways, in reality, it's more or less the same as of now. So far, we have been involved in writing 3 books are already published, and the 4th one is in the editorial process nowadays. We have been working on content-centric networking, which is a future internet architecture. We have been working on sensor networks, and then we have also worked in um, from the cybersecurity aspect in smart cities when it comes to different models, applications, and challenges. Having said that, I also believe, before I jump into my topic of the day, I also believe in interdisciplinary research. And I encourage everyone on this call, if you're a student or if you're a faculty member, um, always try to get out of our comfort zone because that helps a lot. And comfort zone, I mean, when it comes to your research, you should not be just focusing on your one or two topics. You should always be open to different topics and even different departments of your schools as well. It doesn't have to be computer science or electrical or computer engineering only. As on this slide, you can see that I was open to talk to a person completely from a different department. He was from the Department of Mechanical Engineering, and we had a chance to work with him on a topic which was completely different from what usually mechanical engineers do. And this is a professor from MIT that we had a chance to get published with back in 2018. So just to give you an example, I mean, it's an interdisciplinary research example I wanted to put on table. So I like this picture very much. Now I'm going to go into the topic now. And I'm sorry if it gets too technical, but I promise I try to be at a very high level so that if there are some students in the talk, they should have, rather than get scared out of the topic, they should be more interested into it. So how vehicles would be connected if it was not for wireless connectivity? So I like this picture to show the analogy. If there was no wireless technology, how we could have had a concept of connected cars to begin with. But obviously, this is not the like a reality of today's vehicle. So let's see what we have in our today's smart car or vehicle. So you can see I have what we have done here is that I have listed all the possible sensors, all the possible technologies that can come with a fully loaded smart car. And I have grouped them into 5 different applications of a smart car. Okay. What it means is, if you look at here, for example, when it comes to powertrain system, we have a sensor in battery, we have a sensor in transmission, we have sensors in engine, we can have a sensor at exhaust emission at the backside of the car. When it comes to infotainment and telematics, okay, that's very important to us as a computer science or engineer background. What it means is that you're talking about audio visual, like camera, you're talking about head display of your vehicle, you're talking about navigation, you're talking about telematics that can include your cellular coverage, that can include your Wi-Fi coverage within the vehicle, and that can include a lot. So obviously there are applications, believe me or not. So when I show this picture, there are two ways of looking at this picture. One way, okay, fine, this is a smart car and it has a bunch of sensors, all right? This is one way of looking at it. And then there is another way, and I want you to turn on your research mind. I want you to put a lens in your eyes as a researcher. And now if you scan this picture is giving you a bunch of research topics. This picture is giving you a bunch of research problems. If you belong to a mechanical engineering department, you can look into powertrain systems. If you belong to computer engineering department. You can look into the infotainment telematics systems. If you belong to a networking research background, you can look into, driver assistance system and all these topics out here. Imagine when you're talking about making them automatic, when you're talking about making them completely autonomous. If you want to bring AI, artificial intelligence, to each of this itself can be a PhD research topic. So again, it depends how you look at the picture. And again, my job today is not to give you like very, very technical talk, talk on each of these topics, but I just want to also leave on the table that you should have more motivation to talk about connected cars in your research groups. When I continue my introduction, I'm just taking the same car, smart car, and we are talking about a couple of technologies. Again, these are just a couple of technologies. And believe me, this is the most, I would say, technical slide I have. I will not go more technical than this. So we're talking about LiDAR, which is light detection and ranging scheme. This is just one of them. If I go back to I'm just talking about the very first thing, LiDAR. So LiDAR itself has been explored by companies like Qualcomm, continuously being explored by all the mobile companies. Even Tesla had a chance to explore LiDAR technology for detection of objects around the vehicle. Okay, and to categorize, if the neighboring object of any vehicle is another vehicle or another car, or is it a pedestrian or a person walking by, or it's a fog or so forth. LiDAR has been used a lot, and the main application was to crankshaft or position sensor, use the position sensor along with LiDAR, and that's going to help us detect. If you look at one of the applications here, that your car with ACC, and ACC here means automatic or adaptive cruise control. So adaptive cruise control system is like autonomous car. So car with ACC can reduce speed to match the speed of slower vehicle in the front. So with the help of LiDAR technology, one application is that you can adjust your speed automatically when you're taking a drive on the highway. So for example, in here, when this vehicle ahead was coming into the range of a LiDAR technology, the previous vehicle adjusted its speed, which means slow down. But then when that vehicle moved out of the way, now LiDAR is continuously scanning here, and when it finds that there is no object in the front, it's going to adjust its speed and maybe increase the speed on the highway to avoid traffic jam. This is just one simple application. Now, imagine if you have a whole plethora of devices. This is again the same image that I'm using from my very first slide, second slide, I would say. But again, I'm here trying to show you that when it comes to advanced driver assisted systems, and again, these are the color codes applied to all these applications here. So I'm just trying to give you the idea, what are we doing here? Let's try to focus on telematics, because I have a research background on communication side. So I want to focus on telematics here. You have multiple technologies today. Your car is capable of handling LTE, 5G. You're talking about Bluetooth. You're talking about having a local Wi-Fi network. And you're talking about Wave. Wave is a DSRC protocol. It's an IEEE 822.11p protocol suite. Then you're also talking about sensors and their network within the vehicle. And again, excuse me for that, but vehicle doesn't only mean this type of vehicle. It can be a public bus. It can be any vehicle. and you can have Zigbee protocols, which means sensor protocols over the frequency of 2.4 gigahertz, I believe, or so forth. So all these technologies are available today. I'm not talking about something very futuristic, okay? I'm not talking about life in the Mars. I'm talking about these technologies that we use today for many different applications. Just bring them in the car and see what magics we can do. So as you can see, when it comes to advanced driver assistance systems or ADAS, it can use LiDAR, it can use radar, camera, ultrasonic sensors, and these can be the critical applications. Again, these can be critical applications. You can have intelligent parking assistant, you can have autonomous emergency vehicle, you can have lane change, and so forth. So, having said that, we'll move on to vehicle network. Now, and I keep referring to the same picture because I want to make sure that we are on the same topic. It's a quick reminder for myself as well. Now, when it comes to this is obvious that imagine if all the vehicles are smart cars and they have all these technologies that I'm showing you right now. So these vehicles can definitely make a vehicular network. That is pretty obvious. They can make a vehicular network. And what vehicular network means is that everything on the road is connected. Your signals, your road signs are connected to roadside assistance units. These are connected to cellular technologies. They can be connected to the GPS services. They can be connected to the regional national back office, to the warning signs, to the speed cameras, to toll gates, everything. Just like you talk about Internet of Things, just imagine Internet of Vehicles. Just imagine Internet of Roads. That's kind of a newer topic to explore. When these things are connected all together, they can give us several applications. And one of the application could be, I will try to show you a real-time scenario here. And again, in this slide and in coming slides, you will find out a real-time application here. And I will tell you how it can be done. It's not something that I'm talking about very far future, like 20 years from now. It's something you can do it today. So this is a signalized crosswalk, which means you have signal here and people are crossing here. And there can be many reasons when some vehicles may not see pedestrians because of the traffic, because of the distraction that they have, and so forth. So this pedestrian starts walking here, but the guy coming from that side may not be able to see, or the guy coming from this side should need to calm down because remember, we have a green signal here as well to go straight. But this guy decides to take a turn. Now, if there are other areas where we have kind of distractions, there is a very high chance that this pedestrian, if it's a smart city, if it's a connected city, this thing should be reported locally to these drivers here if pedestrian is passing by. What it means is, I'm just using the same slide. I have just hide the rest of the stuff. I just want to focus what we have. So we have an ITS roadway equipment here. We have a management center here. Then we have a vehicle here, which has an onboard equipment. OBE stands for onboard equipment, which is like a communication device. We have a pedestrian, and pedestrian has a personal information device, which can be a smartwatch, it can be a tablet, it can be a phone, And then we have a driver of the vehicle, of course. Okay. Now what happens? First step, pedestrian safety information. Let's say precise location, GPS coordinates, very precise location has been shared continuously with roadside equipment. The next step is this location, if it is connected to roadside equipment where all the other things are connected, this location can be shared, and also the mobility pattern can be shared with the driver. It's a local information. Now, roadside unit is also sharing the same information, vehicle location and mobility, intersection infringement information, if there is somebody crossing the road, if there is some object basically crossing the road or not. And then this guy is also sharing information to the ITS roadway equipment, pedestrian location information, intersection status monitoring, and so forth. Also, at the same time, this roadside equipment is sharing or receiving the information of safety application status and so forth, just managing. And then you have different messages and different set of communication is being done here. What are we trying to achieve? We are trying to achieve information to the driver of this truck to avoid hitting this guy or girl crossing the road. This whole process looks like very complicated, but what in reality happens in a microsecond. In a microsecond. Because we're talking about 4G, 5G technologies. We're talking about the latest communication standards. So it literally takes less than in microseconds, not even a complete second, to have all this communication done. I'm just trying to give you a background of the information. How long it takes for us to send a WhatsApp audio message? Maybe a second. How long it takes us to write down a WhatsApp message? And then in reality, on the back end, you have an entire TCP/IP protocol, you have the entire peer-to-peer networking and so forth for different applications. So just trying to give you that idea. Now, let's go to another area which has been explored, but not to the maximum. If you have connected cars, or even if you're talking about cars, you're talking about some bad guys out there too, which means you need to ticket them. And ticket is like, making them to pay some charges to the government because they were rational drivers, they were, like not following some rules and regulations and yada, 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 yada. So, having said that, this is the area that we should also explore. What are the efforts that have been made so far? Well, we have existing patents for automatic smart ticketing system. Some of the, you can say, patents are very old. Some are still during the last decade, during the last 5-6 years, where people are talking about traffic law violators and issuing citations or tickets for detecting and identifying the traffic law violators. So existing solutions when it comes to ticketing, existing solution includes cameras. It also includes some handheld devices to automatically detect. This is basically a concept from one of the patents. And again, it's called RFID detection. Obviously, there is no future internet support or any wireless communication support application in the market. So whenever you have some sort of violation on the road. And by violation, I mean, let me go back to that. So right here in this slide, there is either you need to have a camera to detect if this guy is over speeding or not, or you need to have a cop vehicle, or a sheriff, or what we call police car or traffic police. You need to have a traffic police car vehicle here in order to detect if they're making any mistakes. And if there is any potential solution in our mind, the only solution that comes in my mind is to avoid those violators. I love this picture. This picture says a lot. I mean, if you want to really start stopping those violators, just be in that way. But again, it's just on a lighter note. Don't quote me for that. Well, in reality, what happens is, and this is the snapshot of my life in South Korea when I was doing my graduate studies there. So usually in the car, you have different sensors, speed sensors, which are connected to the GPS location. So what they do is they can sense your violations. Why? Because if you're over speeding, the car can start giving you a warning that, okay, this is street or this particular area, it has a different speed limit and you are basically over speeding here right now. As you can see, this picture is telling me 60 is the maximum speed, but you are going on 71. Now that means cars can sense our violations in many ways. Remember that picture that I showed you in the beginning? And I'm referring to this picture. If you have these much of sensors, they can sense what you're doing. They can definitely sense what type of violations you're doing. So my idea is that cars can sense our violations. So let's talk about the idea of, for the sake of discussion. There are always unpatrolled areas on highways while depending on manual monitoring system. You cannot have cameras on every corner. Impossible. You cannot have police, traffic police in every corner. So even though the solution is to install cameras, those cameras are equipped with speed sensors, maintenance cost, and limited detection issues. Also not everywhere. They're not possible to be everywhere. However, in near future, we are very much sure that every vehicle will be equipped with communication devices for the sake of other applications that we have discussed so far. Our proposed idea is to utilize those technologies. Nothing new, just use those technologies to issue tickets to the violators autonomously. And when I say unpatrolled area, when I use unpatrolled, what I mean is if this guy is having a patrolling area, you have a police vehicle here. This guy is a patrolling area, but at the same time, what if there are vehicles violating any law, over speeding, and so forth in this area? What should be done here? So my idea is, and again, that is just highway solution, and then this is a urban setting. And in urban setting, you can have the installed cameras everywhere. But again, if you look at this vehicle here, if this vehicle is over speeding, who is going to catch it? Nobody. It is out of the range of camera. It is out of the range of police vehicle and so forth. Look at this vehicle. Who is going to catch it? They're driving at the speed of 75 miles per hour while the limit was 60, right? So there can be many scenarios, basically. And I call this system as traffic violations ticketing, or in a short form, TVT. What it means is that each vehicle can be equipped with a secured flash memory, just like black box in the airplane. That black box will be able to store all the violations via inter-vehicle sensors. And whenever there is a police or cop vehicle, we call it smart cop. Whenever there is a cop vehicle, it will periodically send a message for the list of traffic violations. And in response, all the immediate vehicles will send a list of violations and so forth. For this purpose, I introduced different data structures. Again, I will not go into the technical details, but just to give you an idea that how these things will be handled. We have three types of data structures to be equipped with the ordinary vehicle. Ordinary vehicle can be any vehicle subject to. And then for the traffic police vehicle, you will have two types of data structures maintained on a regular basis. What type of benefits we can have if we use communication of vehicles or communication of car to issue these tickets? Well, you don't need cameras, no extra hardware installation required, and you can handle multiple violators at the same time. Right now in the current system, if traffic police vehicle is stopping one guy, they cannot stop the other three guys violating the traffic rules. With this system, you don't have to stop somebody. There will be no unpatrolled area, and we can also get other updates as well using this wireless communication. What is the insurance status of vehicle? What is the violation history if this vehicle has been used in a lot of bad things? And then so forth. Our transportation department can be updated on the runtime. So I know we have a 1 hour session. I want to be respectful to our time. So believe me, just hang on with me for a couple of more slides and then I will be open for questions. Just to give you the idea when it comes to future vehicular cyber physical system. Again, my idea of today's talk was to give you some of the feeling of different topics that you can, in your near future, you can go ahead and start exploring. And I will be always happy to help people from this audience if you need any guidance and so forth, especially to the faculty members, if your labs or if your students are working or interested, or if you guys need some help and in some publications, please feel free to reach out to me, and we can collaborate on topics like robustness, control over networks, real-time, sensor-actuated networks, and so forth. Now, having said that, this last thing, but when I talk about smart cities, smart city notion is everywhere. Okay, this is not something in US. This is not something only happening in India. This is not something only happening in Europe. It is happening everywhere. I know that Smart Cities India is one of the initiative. I just did some Google search. It's from Jaipur, from Indore, from Ahmedabad, even from Pakistan you have, and then in US, of course, San Diego, and there are a lot, and then you have something happening in China as well. So you have, and then in Miami and IEEE smart cities and so forth. So smart city notion is everywhere. There can be a question that comes in our mind that what is this smart city thing? I call it connected communities. I refer it connected cities because nothing can be smarter. And again, remember this thing to all the students. Nothing can be smarter if they're not connected. For example, your smart watch. You call it smart because it can connect to your phone. It can connect to the internet. You call your TV smart TV because it can connect to your phone. It can be connected to the Netflix or other applications. So you will call in the same way you will call your vehicle smart if it will be able to connect to another vehicle. And in the same way, you will call any city or community smart when they all will be able to be connected for different applications. So with that, I'm open for any questions if you have. Dr. Ramesh?
Hello.
Yeah.
Good evening, sir. This is Dr. Bindu Thomas again.
Yes.
Thank you for a wonderful talk. I have a couple of questions coming up, but before that, I would like to actually, sum up briefly about what you talked for the audience.
Yes.
Yeah. Well, it was definitely an interesting talk where the professor explored about, brought to us the possibilities of vehicular network and its real-time applications. And he also told us more about how we can have connected communities, cities, and also he discussed about various research problems, especially by showing an automobile. So he mentioned that when you look at it, you will get way number of research ideas if you open up your research mind. So it's a great thought-provoking picture that he presented, where many of the researchers who are fascinated with automobiles and communication technologies can network and work on those research problems. He also mentioned about how cars can sense if there are any violators in terms of the sensors that are present in the vehicles and the GPS, how it tracks the GPS location. And he also gave us a lot of ideas and also presented some of the challenges that we could come across. And definitely a lot of problems in terms of how these controls over the network and the robustness and the safety issues and security and various research gaps that he put forward. I think it's a great opening for many of the researchers who are looking into such a technology and currently working on it. Thanks again, Professor, for opening up your research thoughts and being open to network with the researchers out here in our country. And we're very happy to have you. In fact, it's a very interesting topic. We actually got to get a lot of research ideas from this, very compact presentation that you presented. Least number of slides, I must say. And it was way more, ideas and thought-provoking pointers that you gave us. Thanks once again for being on with us. And now I would like to look at what the questions have been put forward by our participants. Can I go ahead with the questions after? There is one, Mr. Rana.
Yeah, Professor Syed, can you please stop sharing? Professor Syed.
Yes. Oh, you want me to stop sharing this?
Yes. Yeah, you can make stop share, please.
Oh, I'm sure you didn't get. Was I audible all the while?
Yeah, you're fine. You were absolutely fine.
Thank you.
I'm sorry, guys. I have to, the last thing I want to do is to scare my audience with my very early morning face. So I'm sorry I have not turned on my camera.
That's fine. Thank you, sir. Just want you to answer a couple of questions that's coming in.
Sure.
Yeah.
Where are the questions? I don't know if I can see them.
Yes, I'll read it out for you.
Okay, perfect.
It's asking about a project. Can there be more features be added? Well, it's kind of an incomplete question because I'm not able to see what the project is. If the participants out here, please unmute yourself and talk to Sir on that particular question you posted. Rana Afreen. Please unmute yourself and you can directly talk to Sir on that. Which is the project idea?
Actually, one question is here, Professor. The whole idea of ticketing is to charge the violators and minimize accidents. If the solution you propose does not stop the violators, then it fails the purpose.
Okay.
Is it
So,
correct?
well, I mean, I got the question, and I will try to
Yeah.
answer that in a
Oh.
way that the thing is, you have right now in the current system, you have unpatrolled areas, right? Like you don't have either camera, or cameras will never stop. Cameras cannot stop a violator, and cameras cannot stop accidents. Camera can only detect them. That is it. My point is, rather than installing cameras in every corner of the city, which is practically impossible, why don't we use communication system of these cars, which are smart already? And in that way, government can save all that money that they were supposed to have on cameras. Now, the thing is, why do we have cameras here and there? We have cameras for two reasons. One, what happened on the road? Second, who did that? So, and by who, obviously, they don't detect somebody sitting in the car. They detect the car itself by scanning the number plate. That is the ID of car, right? We can use a communication device to be unique ID of the car using their MAC address. And having that, we can avoid the requirement of cameras every corner. So my system is not to stop violators or stop accidents. My system is to give them tickets, which they're not getting in the current system. Many people, especially the taxi drivers, for example, they have understood that which streets are not covered with the speed cameras and which streets will not be covered with the traffic police vehicles at certain time of the day. And these taxi drivers will drive so fast and that can cause so many accidents, right? But if they will have this thing in their mind that their own vehicle is now capable of keeping the history of all the violations, believe me, there will be a lot of reduction in the accidents. I hope this answers your question.
Yeah, yes. Thank you, Professor. One more question is here. How effectively do you think we could implement smart cities in India?
Well, Indian government has been, investing a lot, and that is the reason that you have seen all those initiatives that I was just showing on my slides. Um, there are definitely plans, I believe, in India. I have never been to India personally. I want to visit India one day, hopefully, when things get better. But all my Indian friends here in US or in Korea, I have a lot of Indian friends, and what I hear from them in terms of technology, that things will happen soon.
Thank you very much, Professor. Thank you for that answer.
Sir, Syed, I have a question. Yashwant
Okay.
here. Yeah, whatever the technology that you have showed, that is magnificent, and I am working in the IT industry from past 8 years. and I'm working with the Jaipur Smart City project as well. Yeah, I worked in the telematics domain for a couple of years. So
Perfect.
now, in the telematics domain, I just want to have a question here. So when I worked previously 5 years back, there was an OBD port which will communicate with the car engine
Mm-hmm.
and which will give the driver behavior like overspeeding or
Mm-hmm.
hard braking or a sudden U-turn or any kind of violations can be detected from that small device.
Mm-hmm.
So that will be, sends those violations to the cloud. From that cloud, we will be getting the data. So that was the previous technology that we had. So is there
Mm-hmm.
any improvement on that? Do each car, a car to car can talk each other, or they can communicate each other so that without intervening of an admin can see the report, the car can slow down its speed or its prevent the incident before doing that, right? So is there any technology like that now, as of now?
Well, you may have heard of, and thank you very much for actually supporting all the idea that I have presented, and that shows that we are going into the right direction. The thing is that when you have autonomous cars, for example, Tesla, right? Tesla has a
Yeah,
feature of
autopilot.
autopilot. Now that means now you're completely depending on cloud, you're completely depending on communication, right? And you're completely depending on the sensors of the vehicle. So once you have more than 50% of cars autonomous on the road, then it means you will need these algorithms to come into play and maybe predict accidents and stop them.
Yeah,
Right now, the problem is that how many Teslas do you have in one city, right? It's not a very large number.
yeah,
Many people still want to drive cars by themselves. I mean, personally, I believe that this technology is very important to be implemented. But when it comes to trusting a autonomous car with my family, with my that's kind of thing to handle. So to answer your question briefly, there are many advancements, especially Qualcomm's V2X chipset that they have recently introduced. They're talking about 5G. They're talking about using cellular technology to predict accidents and to stop them. But again, cellular technology is already very equipped. It has a lot of burden from our cellular phones already. If you will use existing infrastructure to provide connectivity to the cars, it's going to add a lot to that infrastructure. And in cell phone, if something happens bad, the maximum disadvantage is that your call will get dropped. But if you're depending connected cars on that network, and drop off the message when it comes to car will not mean call of the drop. It will mean an accident. So again, it's a lot of trust that needs to be built on the system.
right, right, sir. You're right. Uh,
Thank you. Thank you.
Thank you.
Any more questions? Otherwise, we will be winding up the session.
Yeah, one more question is in the from Ida Singh. How is different than speed governors?
Well, I have to understand Kishitij saying I have to understand what you mean by speed governors. Is it like a term used in there? If you can tell me what a speed governor is, then maybe I can answer your question. You can unmute yourself and you can talk to me.
Am I audible?
Yes.
Am I audible?
Yes,
Speed
yes.
governor is a device. The speed typically on an Indian road and school buses specifically, they speed all so that the school bus driver speed. So I want to know how your idea sounds very novel, but how it is different from already existing speed governors. See, one sure that we'll have to install less hardware, so like cameras are more costly than a black box for sure. But the speed governor also like you for the cars, yes, but environment.
Yeah. Now, thank you for making it more clear. I know that there are certain countries or certain geographical locations with certain limitations on what you can actually do to the public vehicle. In case of a school vehicles, mostly they are governed by the government, and government can have a speed governor or speed management systems, right? So in order to, okay, this vehicle will never go beyond the speed of 50 kilometers per hour. Okay, this is, I'm guessing, what speed governor does. Now, the problem is when it comes to public vehicle, I mean non-public private vehicles, when we are talking about private vehicles, nobody would like to have that limitation, right? It's, and especially in United States, you cannot force somebody to, do that way. And it's the same thing in Europe. It's the same thing everywhere. So you cannot force somebody to not be able to drive faster than what is allowed on the road. Yes, you can give them tickets. You can give them violations. And that's where you will define who is a good driver and who is a bad driver. And who is the bad driver, let's increase the insurance premium for that guy. If he's a bad driver, let's increase the sales tax of a new vehicle for that guy. So if you know what I'm trying to say here, that we need a lot of data to do analysis. And by the system I'm proposing, we can get a lot of data. Imagine if you know about some vehicle owner, that how many vehicles he has, and out of those vehicles, how many vehicles he drives fast, or he drives, very unprofessionally. And now if the same guy goes for buying a new vehicle, include additional tax for them. So they should pay the penalty price. And that's how system can work. But I cannot go and ask all the manufacturers, let's say Toyota or Maserati or Audi or anybody. I cannot go and try to govern their speed, because that can cause a lot of trouble legally, because these cars are known for speeding, and if you will try to control their speeding without any patent or without their permission, they can come after you in a legal court. So there are so many managerial issues, I'm afraid. Thank you.
Professor Syed, I have last question. Again, it's Yashwant. So we are talking about the smart cars, right? Like the smart cars, which will give all this functionality together. But as of now, the problem is most of the people have the car which is not smart. Okay, so how we can consider those cars as well in a city or in a smart city kind of thing to communicate each other? Is there any way to make a non-smart car to a smart car? Any idea on that? Because we have a lot of normal cars which we don't have a lot of smart cards in the city. Maybe here and there, or out of 100, there may be 10 smart cards which will communicate each other or something. But a lot of 90% of the cars are not smart. So what is the approach to make the non-smart car to make a smart? So is there any enhancement there? Is there any workaround there?
Yeah, I think Yashwin, I think it was you talking about the CBDs or OBDs, right?
Yeah, OBD, yeah.
Yeah. So basically, there has to be work done, but we have a lot of OBD manufacturers or OEMs, for example, Desco from Japan, or there are some other companies as well. They're creating these devices which you can connect to any vehicle and make them a connected vehicle, and make them, like put some 4G SIM card or put some, Wi-Fi spot, or just turn on the router that can cover 5.9 gigahertz. And 5.9 gigahertz is the frequency where V2V communication happens. So there are many ways that can be done, but of course it's a good research topic too. Uh, how to incorporate. I know one of my friend from Georgia Tech. He was doing some research on um, detecting a vehicle without any communication device. So basically using lidar technology or ultrasonic sensors.
Yeah.
So obviously it's going to be challenging. It's because just imagine the same way cell phone technology has emerged, right? 10 years ago, we didn't have smartphones everywhere, right? Then even 5 years ago, uh, even among our society, among our friends, some of our friends were using same old Nokia phones, and some of us were having hands on Samsung phones with WhatsApp and Facebook and yada yada yada. And then later on, technology emerged. There were multiple vendors coming in, multiple innovations coming in, and now everybody, has a smartphone. Everybody knows how to operate YouTube. Everybody knows how to operate WhatsApp. So it was a transition phase, and in the same way, in connected vehicles, there will be a transition phase too.
Right. Got it. But I saw one device, which is very interesting device while I travel to Israel, which the device called as proximity sensors. That proximity sensors can be installed to the any of the existing vehicle in Israel, so that it can detect the vehicle that is or an object um, that is in front of that vehicle and stops immediately by itself. The car will slow down by itself uh, uh, when a object has been detected, and the proximity has been very less, and it will trigger an alarm also. So that could be a very great idea that in all our smart cities can also incorporate those technologies in order to make it's a normal existing vehicle or a non-smart vehicle to smart, right? So keeping that in mind, so are there any other technologies like I'm sure that OBD port will do it, because the smartness will come from the OBD port where it's going to communicate with the engine, and but it will not communicate car to car, right? It won't communicate with one car to the other car. So in order to improve that, so any specific device which can be installed to existing car and that can communicate with police cars or petrol cars or any sort of car that can be useful in that way. So I asked the question in that way.
Yeah, so you can definitely check the products from Desco. And Desco are creating products depending on 82.11p protocol, which is your dedicated short-range communication protocol, which comes under the Wave protocol suite that I was talking about in the beginning. And that OBD is, I mean, it's another type of OBD that will enable your car to be connected to your local other
Okay.
cars.
Right. Okay.
So,
Okay.
and then you can design applications on top of in an application layer.
Right.
Yeah.
Right. Thank you very much for the
Thank you.
information.
Thank you, Professor. We're almost through with the questions. The one, I'm not sure if you answered, does your framework provide robustness against adversary in order to build trustworthiness, speedy adaptation of the smart cities?
Yeah, so this idea of a smart ticketing, it's kind of a one of, I would say, pioneering idea for using future internet technologies. And when you start something from the scratch, there are many areas to be explored. And when IEEE Mysore subsection reached out to me to give a talk, I decided this topic not as a complete solution to the problem, but as a solution that will initiate a lot of research questions to be explored so that this thing should become more mature. So obviously, trustworthiness and speeding adaptation of smart cities, it's a big question to be solved. And any algorithm or any technique that can bring robustness will be, always welcomed by the research community. Right now, I cannot say this thing that all the systems in the smart cities are completely trustworthy, because there are always cyber attacks, there are always cybersecurity issues. That's a different topic to be explored. But yes, at least we are moving towards the smart cities with a lot of applications at the moment.
Thank you, Professor.
Yeah, yes, ma'am, please conclude.
Putting this question. Yeah. Coming to the end of the session, and I take the opportunity of thanking you for being, so open in terms of giving us a lot of research, thought-provoking gaps that we fit today, and gave us a lot of inputs on how the research can move forward, especially Yashwant posing a lot of questions. We thank you for accepting our invite and giving this very informative, very useful community of IEEE at Mysore and Bangalore. Professor, thank you once again for accepting our invite.
Thank you all. I really appreciate it.
Thank you. I also like to thank the Chair, Mr. Chari, the office bearers, Dr. Sudarshan Patil Kulkarni, the treasurer, the secretary, and the other XCOM members of the IEEE Mysore subsection for participating and associating in this webinar session today. I wholeheartedly thank all the participants for actively contributing with their questions and being a part of this wonderful webinar session. Thank you all once again. Have a great evening.
Thank you.
Thank you.
Thank you.
Thank you.
Professor, thank you. Thanks for your time.
Thank you.
Of your busy schedule. Thank you very much. I will.
No problem. Thank you. Thank you.
Thank you, Professor.
Bye.
Thank you. We thank all the participants. I hope all of you downloaded the certificates. The certificate link is in the chat window. I request all of you to download the certificate from the link which we have pasted in the chat window. Thank you all.